Welcome back, Business BAS 121. We're going to go through Chapter 8, Example 8.2, a profit model. And these Excel worksheets are all in your Blackboard site. You can download and follow along with me. So in this example, they're talking about determining a profit model. And it's very similar to what we did in the last class, except remember in the last class we always made this very simplistic assumption that units sold and units produced were equal to each other, and we said at the time that's probably not accurate. Well, this model tries to take that into account. For example, just because you produce it and how much you sell rarely are going to be exactly the same over a period of time. So our variables are P's for profit, R's for revenue, total cost, unit price, unit cost, our fixed costs. S stands for our quantity sold, Q for our quantity produced, and D is going to be our demand. And remember back to BAS 120, we talked about driving a demand function and all that. So here we have, remember as a reminder, our total cost is equal to our fixed cost plus our variable cost. Well, our variable cost is simply our per unit cost times the quantity produced. That's how much it costs us. Revenue is going to be revenue equals our unit price times the quantity sold. Now, just for the accounting purists, this model is assuming we're not getting into your costs being held in inventory, which is what an accountant would actually end up doing. Just a caveat for the accountants out there. There's a little problem with this total cost factor because some of your costs would go into inventory. But ignore that for now, because what we're trying to learn is different models and the use of Excel for those models. So the quantity sold would be the minimum of whatever my quantity demand is or the quantity I produce. So there might be lots of demand, but if I didn't produce any to sell, I can only sell up to what I produced. So my quantity sold is going to be the smaller or the minimum of whatever quantity demand is compared to the quantity I produced. So if you put these two together, revenue will be equal to my unit price times the minimum of whatever is demanded or whatever I produced. And profit's going to be the same way. Profit is going to be my revenue, which I stole from here, minus my total costs. And we've given you a demand function, and if you remember back to the last course, we've made this a linear demand function to keep things relatively simple. So here are my assumptions. I've again started with a unit price, starting price increment, so we can look at what's the impact on our profit at different price levels. We've given you what our demand function, the slope of the demand function, and assumption for the constant for the demand function. Down here I've added other assumptions. Notice here I've just locked in on these assumptions here and pulled them down. Unit costs, I made an assumption of 250, fixed cost 3,000, and units produced 9,000. Now if you notice over here the results, our demand function is calculated. You see the formula up here. It's calculated based on the demand function you gave us. So in this situation, we produced 9,000 units, but we could have sold 9,500. The demand was actually higher. But the quantity sold, the next column, is going to be whichever of these two numbers is smaller, which should make sense. I can't sell something I didn't produce or make. But if there's no demand, I can't sell it just because I produce it. So the quantity sold is going to be the smaller of the demand or the number of units we produced. Total cost, remember we walked through this. Total cost is going to be our fixed costs plus our quantity sold times our unit cost. Revenue at a unit price is our price times our quantity sold, and profit is just the revenue minus our cost. Hopefully you're getting familiar with all these interesting things here as you look down. Note we begin to make profit, and then just like in the other first section of these courses, our profits are maximized somewhere around, eyeballing this, somewhere around a price of 24 per unit. But of course we can go use Risk Solver. Remember, I'll walk you through the steps. You go to Data, you go to Solver, and then you can say set my profit to a maximum by changing the price. And you just hit solve, and it gives you the exact price. I've rounded these to cents. So 23.75 is the price which maximizes our profits. So the other power of this is, what if we think the demand curve's a little different, or if our fixed cost changes? The power of the Excel is it gives you the flexibility to do a lot of different assumptions or change your assumptions. So I encourage you, when you set up your Excel models, to give yourself the flexibility to change the assumptions, and so that you can see what happens down here. So for example, if our fixed costs go way up, right, now we're not going to make nearly as much, and notice that our a lot of things are going to change. Change it back to 3,000. And there you can go. I encourage you to build one of these models. And if you have questions, let me know.